Do show VLAN brief. OK. Now the switch has a VLAN. Don't worry about these below. Let's just look at one. There is a default here. Then the switch is created by default. What do these all refer to? If you create a switch here, this has a default Ethernet port. It's a 4x relationship. If you write one, it will create 4 interfaces. Then actually, these are the 4 interfaces we created. All 4 interfaces now belong to VLAN 1. You did not configure anything. But these interfaces have their own VLAN ID. Is VLAN 1. All we have to do next is put 0 and 1 into VLAN 10. Put 2 into VLAN 20. That is, put these 3 interfaces respectively where they should be placed. First we have to create the VLAN. VLAN 10. VLAN 20. After creating, I strongly recommend that you do this. We can give the VLAN a name. Let's say it's called PC. PC is equivalent to adding a note to this VLAN. Let's check this VLAN. Show VLAN brief. It will have a name in the suffix. Behind this VLAN 10. It is VLAN 0010. This is a way of expressing. After 20. A PC is written here. This is the name we just gave this VLAN. For example, if you want to assign these VLANs to the technical department, just write a technology for VLAN 20. You write a financial statement for this VLAN 10. While you are viewing, the various departments can be divided according to these names. Check what VLANs the switch currently has. There was only VLAN 1 just now. Now with VLAN 10 and VLAN 20. This is what we created. After creating, we are now going to divide these interfaces into different VLANs. Enter configuration mode. First enter the 00 interface. That is, the interface of the switch connected to PC1. It belongs to VLAN 10. So how to change it? I teach you a command. Switch port mode. I enter a question mark. There is a private VLAN here. This you will learn in the NP stage. Then there is an access and a trunk. These are 2 types. There is another one that everyone is using now. .1Q tunnel. This you will learn in NP. We only learn these 2 in NA. Let's change the access now. We divide it into access types. Then after changing to the access type, we need switch port access again. We need to assign VLANs to it. VLAN 10. We can now look at this configuration. Do show run interface E00. OK. Let's take a look at its configuration. We first changed it to an access mode. Secondly, change it to VLAN 10. Here is the configuration for this interface. Then we exit. We also perform the same configuration for the 01 interface. The 01 interface must also be in access mode. Switch port mode access. Then switch port mode access VLAN 10. When we are done with this now, let's exit and take a look at the situation of the VLAN just now. Show VLAN brief. This is VLAN 10. Interfaces 0 and 1 in VLAN 10 have entered VLAN 10. Just these interfaces are in VLAN 1. After we divide, these 2 interfaces are in VLAN 10. Then we now first look at ARP on PC1. Here it shows that the ARP table is empty. Because we don't have data access right now, I can give a simple explanation. It's not working now. Both of them are VLAN 10. They don't span VLANs yet. We haven't configured yet. Let's review the process. For example, PC1 now sends a data here. hit a tag 10. But let's not talk about the tag issue. What I want to ask you now is, for PC1. PC1 is 10.1. PC2 is 10.2. PC1 holds its own mask locally. Add the IP address of the peer. Calculate whether PC2 and PC1 are in the same network segment. Should be the same network segment. Then, if PC1 accesses PC2, it is now going to send an ARP request. That is, a broadcast packet. So now this message is sent. Sent to this switch. This switch first starts learning. Under this interface, I learned a PC1 MAC. After that, it is flooding the interface to which VLAN 10 belongs in the current device. Because it doesn't know yet. Where exactly does this broadcast packet go? But it's flooding. Flooding from its native interface belonging to VLAN 10. It localizes these two interfaces. Except that it received from the 00 interface. Then the broadcast data packet sent will only be sent from the 01 interface. That is, it will look up representations from here. Then post it. So we just finished creating VLAN 20 here. We now divide this 02 interface into VLAN 20. Let's configure. First enter the E02 interface. Switch port mode access. Switch port mode access VLAN 20. It is different from other equipment VLAN. Show VLAN brief. Check it out. Now for interface 2. It is already in VLAN 20. We also configure an IP address for the third device. 192.168.10.3. We now have 3 devices in the 10.0 network segment. Let's take a look at the message next. I asked PC1 to wait a while to ping PC2. Logically speaking, it works. Because VLAN 10 comes in here. Our ARP must first send a group. Then from this interface, the ARP broadcast should pass. It should come back with an ARP broadcast from here. After that, our ping packets will pass through. So let's wait a moment to get the packet under this interface. We can get ARP packets. This is the first point. Before we talk about VLANs. If by default all devices belong to the same VLAN, then this interface will also receive ARP broadcast packets. Because we're going to broadcast. Let's see now that the VLANs are divided. Will this broadcast be sent from this interface? So we can see. After the VLAN is divided. Is the broadcast data packet really unreachable? Let's take a look. We get a packet for interface 02. Let's do a demo. Let's get another packet from interface 01. Let's do a demo. This thing is not very important. Just to show you a phenomenon. You have to verify whether the knowledge is correct. Get the data packet of interface 00 and only see the reply from PC2. Which is equivalent to. Now this packet. It is to wait a while to reply. Including the package that will pass through ARP. This is through ARP. This is without ARP. We set our sights on this. Let's try to ping now. We start ping here on PC1. Ping 192.168.10.2. Ping PC2. Then what we should be able to see here. Okay.